it says, recall that log of base b of x is the definition of the exponent which b must be raised to in order to yield x, which is b greater than 0. Part 1, use this definition to compute this. Okay, so if I have 2 to the 5th power, I'm going to go into my calculator, and I'm going to type 2 to the 5th power. 2 to the 5th power. And that is 32. Okay, so this is really saying log of base 2 of 32. Well, if I type this into my calculator, I'm going to say log of 32 divided by log of 2. So I'm going to go into my calculator, and I'm going to type log of 32 divided by log of 2. Okay, and when I do that, I'm going to get, on your interim review, AKS 38. So this is going to be 5. So you're going to use the definition to compute this one. So since this is in base 10, okay, what's going to happen is you can actually just type this straight into your calculator because your calculator works in base 10. So you're going to say log of 0.001, close parentheses, you're going to hit enter. You're going to get -3. Okay. C, use this definition to compute ln of e to the 3rd power. So you're going to type ln of 2nd ln to the 3rd power. That's going to give you 3. We also know that ln and e are inverses of each other and they cancel each other out. Okay? So explain why log of base b of b to the y equals y. Because, just like what I said, log of b are inverses. So it's kind of like how exponential and log are inverses, and they cancel each other out. Okay? Part 2. It says evaluate 10 to the log of 10. Does that say 10 on your paper? Yep. Of 100. So 10 to the log of 10 of 100. Now I can type this straight into my calculator. 10 raised to the log of 100. And I'm going to get 100. And the reason why that's going to happen is 10 raised to the 10 log 10 is going to cancel out. So what do you think is going to happen on part B? These are going to cancel out, and I'm going to get the square root of 2. On part C, we've got e to the ln of 8 point, oh no, we got 89. Sorry, those are so small. So then that cancels out, and we get 89. So explain why this works. Because they're inverses of each other. So if I took this and I wrote it into exponential form, I would start at the base, go to the x, and finish here. So I go b to the x equals log of base b of x, which is the same thing on both sides, right? I know. Look at your paper, though. I know. You got to squint, turn your head to the side. All right, a cup of coffee will, over time, cool down to room temperature. The principle of physics, I'm reading. A principle of physics governing the process is Newton's law of cooling. Experiments with a covered cup of coffee that show the temperature in degrees Fahrenheit of the coffee can be modeled by that. Hey, so fun fact, totally irrelevant. I totally did this experiment, not a cup of coffee, but hot chocolate, to try to see how long it would take before the hot chocolate would cool. We actually did it in my Gen Chem class in college. Like, that's what we did. Like, we drank hot chocolate. It was cool. So your hot chocolate will only hold for like 7 minutes, and then it'll get cold.
Really?
Yeah. And for every degree that it drops outside, it'll take off like 15 seconds.
Is that the same with coffee?
I don't know. I think it's the acidity affects it, like the pH level. No, it's crazy. It's so cool. Okay, but it was a similar equation to that. I don't remember it exactly. That was like 6 years ago. That's fine. All right, explain using the structure of the expression why the coffee temperature decreases as time elapses. So the first thing that I'm going to notice is that there's a decrease. Okay, so there's a decrease in the rate right here. So that's going to be 0.08, which is going to be the rate. Okay, and we know that that's going to be decay. All right, what is the temperature of the coffee at the beginning of the experiment? Well, what's the initial value right here? Oh, okay, cool. 110. All right, so it's going to be 110 degrees. So your coffee starts off to be 110 degrees and then gradually gets colder as it sits out, right? Yeah, that's hot, right? I mean, think about it, though. Your internal body temperature is 98.6. So really, is that hot? I don't know. McDonald's coffee is like 200 degrees. It's fine.
Yeah, literally.
Okay, so after how many minutes is the coffee 140 degrees? What? Am I reading that wrong? How many minutes is the coffee 140 degrees? After how many minutes is the coffee 100 degrees?
What?
I don't think so. Bro. Oh, it's totally, I totally messed up on the last one. Look what I did. Okay, so this should be the initial, but if I plug in 0 in here, I would get 110 times each of the 0 power. That would actually be 1, right? So this would be 110 plus 75. So what's 110 plus 75? That sounds about right. Yep. 185 degrees is the initial, right? Like if I plug in 0, that's what it's going to be. That makes more sense. I was like, 110 is not hot. That's like less than bath water. Okay, anyways. So after how many minutes is the coffee 140 degrees? So we're going to take this equation. We're going to set it equal. Excuse me? No, that's in Fahrenheit.
That's hot.
What's that?
Celsius would have been even hotter.
When you get in a hot tub, it's like 115 degrees. Hot tub.
Girl, that's on my bath water.
Yeah.
Oh,
So you're going to take this and set it equal to, I think that says 0.0. No, that's 0.08. Sorry, I can't see worth a lick. Okay, so you ready? So we're going to set this equal to 140 and we're going to solve. So we're going to subtract 75 from both sides.
75 from both sides.
And that's going to give us 65 equals 110 e to the negative 0.08 t, right?
You know that.
We're going to divide by 110 on both sides. So e to the 0.08 t equals, and I'm going to put 65 divided by 110 in my calculator because your girl doesn't know what that is. It's 0.59. Why and cook? Yeah. Yeah.
Okay, that's the reason, right?
Yes. Okay. So then now what you're going to do is you're going to take the ln of both sides so that you get rid of this e. Shh, you're yelling. Okay, so you're going to take the ln of both sides. So it's going to be ln of 0.59 equals negative 0.808 t. And the reason why that e disappears is because if you take the ln of both sides, those are inverses of each other, right? Okay? Then you're going to divide by negative 0.08. And I'm sorry, this is at the bottom. I promise I'll move it up in a second. So I'm going to type into my calculator. This is going to be ln of 0.59. Did you hit your face? Divided by negative 0.08. And that's going to give you t equals 6.59. So, you ready? For the coffee, it's going to take 7 minutes for it to hold at 140 degrees. So, like, when you go into racetrack and you get their scalding hot coffee, no, Quick Trip. Quick Trip has lava coffee. I'm serious. Okay? It's going to hold for like 7 minutes at 140 degrees. Like, that's going to burn your tongue. Okay? All right? Can you take a moment? Can you try to figure out how long it's going to hold at 100 degrees? So set this equation, but equal it to 100 instead of 140. Try it. Go. Shh. You're going to take 100. Set it equal to the equation. Okay? First thing you're going to do is subtract 75 on both sides. That's going to give you 25 on this side. Then you're going to divide by 110 on both sides.
Want to be 100 divided by?
So it'd be 0.23 e to the negative 0.8 t.
I'm an idiot.
You're going to take an ln of both sides. So ln of 0.23 equals negative 0.08 t, because remember ln and e cancel each other out. Then you're going to divide by negative 0.08 on both sides. So you're going to go in your calculator. You're going to say ln of 23. Shh. I'm doing math. So that
Oh my God, it's so much
you're
math.
yelling. You're yelling.
I don't think I was right.
Hold on. Hold on. I need a negative. Negative 0.08. So T is going to equal 18.37. So it's going to be 18 minutes that it's going to hold 100 degrees. We like warm coffee. Yeah? Left in a warm room on a summer day. Demons. The graph below shows the temperature of the soda and it gradually increased. The function that describes the temperature of the soda in degrees Fahrenheit after T minutes can be expressed by that equation. Use the graph to estimate C. So, what is C going to be? Hey, I'm talking to you.
Huh?
Use the graph to estimate C. So, what is C going to be?
C is gonna be
It's gonna be the
soda cans. The soda cans.
F is going to be the temperature, right?
And the C is gonna be the can.
What do you mean by cans?
The soda cans. Look what it say right there.
What you mean?
It say soda cans right here.
The number of soda cans, so I'm going to plug that in. Minutes soda can is in the room. That's going to be your T.
Bye.
Girl. Okay, so what is C then? Nope, just me. Okay, cool. Thanks, guys.
See, hold on. Would it be the room? In room,
Why is it C?
That don't make sense.
Isn't it Celsius? Celsius is the Greek. Oh.
I mean, my question is, what else could it possibly be?
Oh God.
Because, like, you're going to take the temperature of the room and then, or what it is outside, and then subtract, right?
Why are we using Fahrenheit and Celsius?
I mean, it could just be them saying, hey, the temp in the room. But, I mean, they haven't given us any other information, right? Like, I'm reading the same thing you are, right?
Sure.
I think, maybe. Use the graph to estimate R. So, C is going to be this temperatures in degree Fahrenheit. So, so it's gradually increasing. So where it's going to level off is the temperature overall. Okay, so the temperature outside. So it's probably like 72-ish degrees outside. That's what C is going to be. Okay, now what is R going to represent?
Right.
The room.
I tried.
Like the temperature of...
The room temperature. Outside the room.
I would do the temperature of the soda can. Because, like, think about it. All right, I got this hot room that's 70 degrees, right? 72 degrees. And then I'm putting a soda can in the room. This is my soda can. Okay? And the soda can is, let's say, like 33 degrees, right?
Mhm.
Like, that's the temperature of your fridge, right? Roughly?
Yeah.
Roughly?
Kinda.
Okay.
Hopefully.
It's not freezing, but it's cold. Yeah? Okay, we'll give it 40. So we're going from 40, which is right here. Do you see the y-intercept?
Jesus.
Okay? So we've got 40, which is the y-intercept, and then it's gradually going up, right? So R, I think, is going to be
40.
your initial value of soda. Okay? What was the approximate room temperature? Room temperature is going to be... What was the initial temperature of the soda can when placed in the room?
40.
40-ish. Okay?